So welcome and allow me to wake you up. This is your after lunch lull wake up talk. I'm going to try to play something really loud for you and see if I can get you awake. No, I hope I won't play anything too loud. So my talk is on what I've really just been doing for a very long time. This is what I really enjoy working on when all the email is done and I can actually get to work on something. This is what I work on basically is real-time virtual musical instruments. And so I'm going to explain why do I use Faust for that. I guess you may already know the answer to that. So it all comes down to what is the best way to get a virtual musical instrument into existence that can be performed in real time, a live performable instrument. I'm a guitar player, and guitar players have very intimate relationships with their instruments. And I want that same intimate relationship with my digital instrument. I want as many dimensions of control or more, and I want it to be as instantaneous or better. And so that led to, this is our current best embodiment of this sort of goal. This is an iPad, and it's got 10 points of multi-touch that you can operate. And just so you know, one touch is infinite dimensional. I don't know if everybody realizes that, but if you make an arc, of course, when you pixelate it, it's not infinite dimensional, but in principle, a continuous arc has an infinite number of derivatives and integrals, and they're all linearly independent. You're talking about an infinite dimensional controller with an infinitesimal piece of arc. Right? You can do a Taylor expansion of that and generate any function from it. So, I know we can't really use that many dimensions, but I just want you to realize that there is a lot of headroom in touch and in arc. And so, don't sell it short. We can get a lot out of it. So the iPad is really excellent, and we're running with it, and it's working. We dream of embedded systems with larger touchscreens with higher resolution that connect to FPGAs or Raspberry Pis, even something easier to program for. And but for now, we're actually doing okay on iOS. And so I have some demos, and I apologize if the sound's wrong. Let's see how it goes. This will be coming straight from YouTube. It's a phone. Another phone. Why is it a phone? Force. It has force touch. Jordan Rudess. So that gives you an idea, and I've got more. I can come back to them if we run out of questions. While I'm waiting for people to think of questions, I'll play more if you want. So that's a sense of what you can do. Just some of the examples. So in other words, this has been out for a while, and it's got people actually playing it. But of course, we're always working on new things and new instruments, and rewritten the entire engine, and so actually have that right over here. There's my little test bed. I might do a demo from that. So this is what it's about, and every single effect and the whole guitar in the guitar examples you just heard were written in Faust, and it would not have happened without Faust. And the reason is it just takes too long to write everything in C++. That's basically I do this as a side thing, right? I had a full-time gig here at CCRMA, and you're allowed to consult up to 1 day a week, and really, it's most weeks it's impossible to squeeze out a whole day. So you've got this little side thing. Do you have time to write 15 effects in guitar with all this modes? No. Well, maybe some people can do that. But if you really are one of the top programmers, okay. But if you're a mere mortal signal processing person, then you need something like Faust to get things happening much faster. And so that's the bottom line. And so this is just a list of all the things that can run in real time. 6 strings, distortion, compression. And this is in 2011 what ran in real time. Of course, now everything runs in real time. This is just some of the effects. Each one has a kind of stomp box graphic. And so the actual Faust in each one of these is usually fairly small. It's like a little flanger. Just go into effects.lib in the Faust distribution, and most of these started there. Some of them might even be identical. There are a few little extra bells and whistles added here and there, but for the most part, it's just that kind of stuff. So this is a review of the performance, and I've got a link to more recent performance benchmark, but we're up in here somewhere, and 2011 was way back here. So this is just how much more can be done, just a rough look. So Faust, why Faust? Well, the way I got to it was I need to develop C++ for audio signal processing as fast as I possibly can. That's all I want. I just want fast signal processing development. I want it to work, and I don't want to spend a whole lot of time on it. And so that was what led to Faust, and I'm still there. But I'm still looking for alternatives. So I'm trying to see if ChatGPT-4 can help me. That's, as far as I know, the state-of-the-art coding assistant. And so I've been trying to do almost any new thing I try to do it in ChatGPT, and I see if it can help me. And so far, no. So far, it is too full of bugs. It's untested code. It tends to use old API. In the case of the Juice distribution, Faust API has been extremely stable, so that's actually been not a problem at all. But the Juice distribution API, it uses older API. You have to upgrade the API. You have to actually go find out what's not being used properly anymore. And so, and sometimes it's just completely out of it. It just goes crazy. It doesn't know. You get into a dark corner of its latent space where it just dreams out garbage. But it's usually hopeful garbage. It's usually garbage that you like. It's like, we should actually implement that. That's actually a reasonable API. It's too bad it doesn't exist. So, and the biggest problem for someone in signal processing and physical modeling is that it really just doesn't know that much. There's just not enough training data, I would guess, on the internet that it was trained on to bring it up to the college level in signal processing, complex variables, calculus. And you just give it a standard freshman physics problem, and it will generally fall on its face because it can't set up an integral and solve it without a lot of coaching. And so I've been coaching it through these things, but it's not really worth the time if you're just trying to get something done. So the bottom line still is just writing Faust by hand, and it will write Faust. So ChatGPT, I wish they called it a generative pre-trained model, because that would transcend the transform, which according to Bengio et al. Is obsolete. Now it should be convolution. So just call it a model, and then we can say GPM instead of GPT. That would be so much better. So 3.5 cannot do Faust very well at all. It's just very, very weak on Faust. It doesn't really understand the semantics very well. But GPT-4 really does understand the semantics really well. And so you even have to kind of work around that in some of the translation tasks. But the bottom line is Faust by hand is best. You can write Faust with GPT, but it tends to be very elementary, not very well done. In anything advanced, you're going to do a lot of coaching. So I just thought I would give you kind of a capsule summary of the development process. What normally happens first is a standalone app. Here's a virtual analog modular synthesizer, following the mini mode pattern. You basically have 3 oscillators and a couple of envelope generators and voltage control filter, the usual stuff, the classic stuff. And it gives you a sense of what you can do with the built-in GUI with horizontal groups of vertical groups going back and forth. And so we take our Faust modules into the Juice framework, because Juice framework gets you to all the various audio plugins in the world, and it's a great help for getting plugins out, audio plugins. And so here's just what it translates as using Faust to Juice. So it's basically the same standalone app, but wrapped in a Juice project. So you have your producer file that you open, you build your Xcode project or whatever IDE you're using, and then you build it, and you see the Juice look and feel in place of this, which is the Qt look and feel. And you also see the GTK look and feel a lot in the Faust world. Those are the two main GUI systems supported by the architecture files, as far as I know. So the standalone app is great for initial testing. I typically use Faust to Core Audio QT because I'm on a Mac. And Faust to Juice is a great way to just get that into a Juice project and maybe just start hacking from there. But as it was already mentioned in a previous talk, we need to be able to bypass pieces of the patch sometime, or which really basically just means let's make small modules. So we make a lot of small modules that we can then integrate in C++, and we can bypass them whenever we want. So you take a DSP file, a Faust source file, and you generate a header file like your oscillator.h, your voltage control filter.h, and then you instance it as many times as you need in C++, and you bypass it when you want, and so on. And that's generally in the Juice framework. That's in the process block where you decide what to run and in what to feed to the next thing. You do your patching at that level. Another reason to get into the more general C++ environment and the Juice environment is so that you can get more general GUIs than what we're seeing, in the examples that I showed you. The Juice team was here. They gave a talk, and we asked a question, and they said that most people tend to use the direct programming approach, using the Juice Paint API, basically drawing on the screen in the Paint method. And so that's very interesting, but I find that very time consuming. And they're working on a new WebView based GUI approach. You basically are going to have an embedded browser that you can use for your GUI. So if you're a plugin editor, it's basically a browser view. And you can look up something like Web UI to get an example of that kind of thing. That's going to be really convenient. In my case, I only want a fast research prototype because I don't do final GUIs. I really just want something that works, from a performance point of view. And so I was actually happy with the original producer's GUI editor. And you can still enable that. You can enable the GUI editor, but it's been deprecated. And so it was time to find something else. And I found Daniel Waltz's plugin GUI Magic, and I really like it. I'm really happy with that. And this is an example of what it looks like. This is the equalizer example that comes with it. So this is the plugin here, and all this stuff is WYSIWYG, drag and drop editor components. Of course, you have to hook these things up. You have to provide a plot source for the various displays, and you have to have a parameter for each of these little strips here. And in fact, these are 3 parameters at least. I guess 4 parameters if you count the type here. That's a combo box, and then you have your basic floating point parameters. And so I can go into edit mode. So this is the editor right here, and I can click edit, and then I can select the knob, and then I can inspect it, and I can then pull up this pop-up parameter that has all the parameters hierarchically organized. So you can get a very nice organization of your parameters, and then select EQ, center frequency, or whatever for the knob. So that's how you hook it up. So the way you integrate Faust in Juice really is you just have to hook up the parameter. You have to make a Juice audio processor parameter that connects to the Faust parameter, which is some slider in your GUI inside the Faust module. And so you hook those together, and once that Juice version exists, then you can hook it up here and you're done. It's really, really quick, fast workflow. I really love it. Very happy with it. So a little bit about these parameters. The parameters in Juice and Faust are different, and it's worth taking a look at that because you kind of have to decide how you're going to synchronize them, basically. In the Faust world, they're in the DSP module, so it's like a slider state. When you call forth a slider like this, you give it a name and you give it a default, minimum, maximum, and increment. Then you build the user interface. Faust has you instance a Faust user interface class. Everything, all of those are derived classes of UI, and then the DSP module is a derived class of DSP. So those are your 2 classes. And so you hand the UI to the DSP and say, build me, and that populates all those pointers. So you have state variables in your DSP module, you build your user interface, and you just got pointers into the state of the DSP module. And that's very different from the Juice world. So the Faust parameters are assumed atomic in hardware. So that means that there's no arbitration between the audio thread and the message thread in Juice terminology. because your audio thread is, what the DAW is providing for your plugin to run in. And then if you instantiate an editor, that will have its own thread, which is generally called the message thread. And so, if you play with the parameters on the editor, they're going to fight with the any usage in the there's two clients for the parameter. And so in the juice world, you have a standard atomic protection. But if it's protected in hardware, the compiler should just make that go away. It shouldn't do anything. And so and Faust assumes that. So and I'm told that in modern processors like ARM and x86 that's taken care of, that you can assume that they're atomic in hardware. So that's why we've never had any issues with that, I presume. And so just be aware. So now in the juice world, the plugins parameters live in both the audio processor and the editor if you've created an editor. So now we have three instances. We have our Faust version, the audio processor version, and then the editor version. So three have to be synchronized. Now, of course, Juice will take care of the synchronization between the editor and the processor. Every parameter has a set of listeners. Every GUI element has a set of listeners. And when you instantiate a GUI element, it will attach to a parameter, and then the parameter will listen to that GUI element. The GUI element becomes one of its listeners. And that's I single-stepped all that, and it seemed like a fairly heavyweight thing going on, and it made me worry about, small system implementations where maybe I don't want to spend that much time. But then I found the raw parameter pointer that you can get, and that's much more like Faust. And so that's really important to know about if you're in a high-performance situation. So we still have to synchronize them, though. And so I thought, well, let's ask ChatGPT. Let's ask ChatGPT if we can fix this by making the audio processor parameter refer to the Faust state variable. That would be, in my opinion, the cleanest thing to do, where you really just have one instance of the parameter. Let's say we don't even have an editor, and we're not worried about the editor. We want the audio processor parameter to simply be, I want to swap it out. I want to tell it to use my DSP state variable. I want to build my audio processor, so to speak. And so I asked ChatGPT, can I make my juice gain parameter refer to a pre-existing memory location? And it gave me a good answer. I would say it's a very good answer. It says you can do that. You just create your own subclass of ranged audio parameter and override these methods, get value, set value, etc. And then it wrote some code for me, and the code wasn't really complete, didn't compile, but it had the right general idea, and I could go look at audio parameter float and finish it off and get it working. And so problem solved. But it was a fair amount of code. You basically have 4 different, instead of audio parameter float, you'll have your own Faust parameter float and int and bool and choice. And so it just seemed kind of heavyweight just to have to keep track of those. Every time there's a new juice release, I've got to, merge any changes and that sort of thing. And so I decided I don't really need it because we've got the raw pointers. We can refresh them whenever the parameters may change. And in a high performance situation, that's going to be when the MIDI messages come in and change them. So in process block, you just compute up to the next event time and then execute that event and then refresh your parameters. And here's some pseudocode that does that. So this is the solution that I think is good enough. So this is where the parameters get refreshed. So the Faust parameter, so you got the raw parameter pointer here, and you cache the raw address of the parameter for Faust as well. And you just refresh by a simple assignment only when it might have changed. And so that would be, right when you process your MIDI message, and you could have a switch that only refreshes the parameter that could have changed as a function of that particular type of MIDI message. So it's really, really quite okay, I would say. And another argument in favor of that is if you single step process MIDI message and see everything that happens down there, you realize that these assignments are a very small percentage of that work. And so that gives you the warm, fuzzy feeling that you've got a lean, mean, fast, optimized implementation. So your MIDI message comes in, it's got timestamps on the sample level. They're actually rounded to the nearest millisecond by default, but you can take it down to the sample level if you want. That's a compile time constant in the Juice framework. You can run audio, you generate audio up to that timestamp, and then you set your parameters, and that's And that's really right. I mean, you still got your buffer delay, so your audio buffer size sets your latency, so you can try to crank that down. But I don't see any other significant delays here. So that's not bad. That should be good. So to sort of summarize what I've been talking about so far, I just have found that Faust is an excellent source of signal processing functions, and they're easy to incorporate into JUICE projects. Faust is still best written manually, and you want to leverage the Faust libraries as much as possible, because that stuff's been tested, and it goes a lot faster. In fact, GPT does its best as a Faust author when it's using the libraries. I find that it writes very pretty code if it knows how to use the libraries to do it. It's when it has to write low-level Faust, the kind of Faust you see in your error messages from the Faust compiler that we all had to learn how to read at some point. That's when it really seems to struggle. It's when it's got to do that low-level stuff. So most of my debugging time with GPT was upgrading API and repairing just complete lapses. There are times when it absolutely doesn't know what's going on. So what I was telling the JUICE team when they were here is that, what we need is JUICE GPT, where you take one of the language models that's used for code assistance, like GitHub Copilot or Amazon Whisper or whatever the latest Google version is. You take a large language model that's already fine-tuned for all the major languages, and then fine-tune it for JUICE using only the latest JUICE distribution, and then hopefully that'll do it. I have no experience fine-tuning language models, but that's what everybody's doing. That's kind of the standard thing. You can do OpenAI has an API for doing this on their GPT-4, etc. So that's what I would really want to do if I were seriously doing this all the time. And if I were on the JUICE team, I would say, hey, I'll do this for you. That would be something to get done. It should be good. Okay, so I'm finding that it's useful for general purpose C++ development and well-known language translation and more mainstream topics. And it's been good for writing unit tests, and you really need to make it write its own unit tests when you use it to write code, right? So you get the code out of it, and you say, okay, give me 100% coverage in unit tests, and you'll have to debug the unit tests as well. So you'll debug the unit test, debug the code, and then get it all running, and then eventually, pretty soon, you feel like it's probably right. Okay, so that was the main stuff that I wanted to get through regarding, I have one more coming, that's right. So another aspect of bringing Faust into the JUICE framework is that you've got to write this create parameter layout function. And so this is part of the process of wrapping each parameter from Faust in a JUICE or audio processor parameter. And so it's pretty verbose. Here's an example of what it looks like. This is not even, so this is just for one float, one int, one bool, and one choice, one combo box pop-up choice. And it doesn't fit on one page. I have to go to the next page to get it all in. So that seems like a lot of typing to me. And I find it's harder to write than normal things for some reason. And so I tried to see if I could get GPT-4 to do it. And in 3.5, I started doing this with 3.5, and it would write things like, and this was written by GPT 3.5. Wait a second, I say this is 3.4 here. It looks like, no, that's an error. This was 3.5. So 3.5 just wrote it, but when 4 came out, I tried it. What is that thing? How do I get rid of that? Is that? I don't know what my screen is doing here. Let me get out of that mode and back in. Something very odd just happened to my display. Yeah, I don't know how to get rid of that. Do you see that? Yeah. It's like some sort of magnification thing. It may be some assistance thing. Well, thank you for the assistance, but I don't need it. Well, I'll just keep trying to dodge it. Let's see, I'll go back in full screen mode. Oh, it's gone, who knows? So many favors. Thank you, software engineers, for all these favors that I don't want. This is some sort of, okay, that was 3.5, and sorry for the typo there. Interestingly, ChatGPT once claimed it had a typo. So, it has to think out loud, right? So if you set up your problem in such a way that it has to just blurt out an answer, then it's much more often wrong. And so if you get it to just state the answer and then explain its reasoning, very often it will state a wrong answer, go through the reasoning, and come up with the right answer. And then you can call it on that and say, well, why did you first say blah? And it'll say, oh, sorry, that was a typo. It actually said that once. So, it's a little sneaky. You have to watch it. It's optimum BS, right? I mean, that's what it's trained to do. And 3.5 is what I would call fairly strong BS, but somewhat weak. And then GPT-4 is very good, very strong BS. And we normally buy it, right? It's like, it's so good, we buy it.
Did you try Bard?
On Palm?
Bard.
On Bard? Yes, I've tried Bard. And for me, I haven't tried it, the latest Bard. I think the latest Bard is on Palm 2, which is a lot better. On the Bard that I tried, I found it to be close to 3.5. And I'm not really, I only try things one or two times to see if it's the best, and then I don't go there anymore. So I've been on GPT-4 consistently. I haven't found anything that is as good, but it's on my list of things to try Bard when it's latest, Palm 2, if that's right. Because I'm going to try everything and just run with the best thing I can get my hands on, and I'll pay $20 a month. Really, your time is worth it. It's really not that much. So now 4 was really interesting. So it was I was happy with my 3.5 solution. It just wrote that thing for me. It was right, and I didn't even have to debug it. That was really very good. But for 4, I was using it again, and I gave it a slightly different prompt where I was trying to set it up in a more general way so that I could use it again. I wanted some reusability. So I wanted to introduce this high-level syntax for parameters. So instead of the Baroque thing you have to say for an int, here it is back here. This is all the stuff you have to say for an int, right? But the actual active ingredients there are your it's an int. It's got a name. It's got a min and a default and a max. And I don't even care about the increment. And in Juice you can't specify the increment anyway. So this is all I want to say. It should be enough. And so I wanted it to write the 2 pages of code from that, and instead of having to type it all the time. Or what you really do is you copy paste the most similar thing and you delete all the parameters you don't need and you rename everything. It's how it goes. And so so this was what I asked it to do, and it generated some really pretty code that interprets this whole thing at runtime. And so what I do now is I create a juice string, which is a raw string literal that I literally did not know existed. This is just one of the little corners of C++ I'd never seen before. So a raw string literal is so raw that you don't even have to quote your double quotes inside of it. And so you really can use your syntax completely unadorned with backslashes. And I guess the scanner only looks for this close paren, double quote to terminate the raw string literal. And you pass that to the parameter, create parameter layout written by GPT-4. So it just takes this raw string literal and it just gives you a layout. And so I'll never, ever create parameter layout again. It's like never again. And so, and I didn't ask for this. I didn't know I was asking for this. You know what I'm saying? It's like, it solved the problem in general in such a way that I don't even have to go to it again. It's like, it's now in my library, which is a juice module.
David. So it made a parser, but did you say write a parser, or you did it?
No, here's my prompt right here. It says create parameter layout to return a parameter layout based on the following abbreviated notation. So I expected, a literal parameter layout that, in other words, I thought that I would give it the notation here in the prompt, and I was just trying to tell it how to interpret it. In other words, I'm trying to symbolically describe my prompt. I'm going to give you a type, a name, a min, default, and a max. And then they're all going to have that form but you need to know that the bool will only have a default. It will not have a min and a max. Also, type choice has choices specified as a string enclosed in curly braces. And so I gave some examples. And so, I've just learned that you want to, give it a lot of context. Nick knows this. You just have to warm it up with a lot of context. It's got a much longer input buffer now. You can tell it a whole lot before you ask it to go. And then you want to ask it to go in step-by-step fashion because it can only think aloud. So you get it talking through things, and that's how you get your best results. And this is all well known. So I elided I could take you to I happen to have it open because I was trying to improve it. I was actually trying to improve the results for today and the next topic. Where is it? So these are all my chats. Oh, it's explained. Well, yeah, let me not get too derailed. I can come back to it. I'll do that in the question and answers if there's any time. Suffice it to say that it wrote some pretty code. It defined a nice little parameter struct, and then it did, it made a little switch statement on whether or not it's an int. So it parses the string literal into words at least. It's got that much of a parser, a lexical scanner kind of thing, and then it switches on int, float, bool, and choice, and it does the right things. And I should say that that while int, float, and bool were perfect, albeit generalized to float, which I thought was interesting. It generalized these parameters to unify them as floats, which the audio processor value tree state does in the juice framework. It similarly insists on, it maps all these parameters to float parameters. And so that there's probably some influence there. So I did have to help it on the choice case. There was some debugging necessary, but it wasn't much. It was just a little disoriented about what goes on here, And when it gets disoriented, it tends to just put out really, it'll start missing, just leaving things out all of a sudden, and it will make up API that doesn't exist. Those are the kinds of things I see. So that was a really happy moment, getting that. And I still use it, and the issue probably never come up again until there's a new parameter type or something. And so there was another case that was fun that I want to talk about, and that was translating Faust to C++. And I needed this back in ChatGPT 3.5, and that's the one that doesn't really understand Faust, but it's seen enough of it to know what it looks like. And so high-level Faust that makes heavy use of the libraries looks just like some kind of functional programming environment where the functions you can just do what the names say. And by the way, it is good to have good names in your functions, and it's good to have comments. The GPT engine uses all that to get oriented. So I needed to translate Faust into C++, and I'll explain why. Just zooming out, why would anyone ever want to do that? Because Faust compiles to C++. Well, my reason was to convert pattern matching into construction arguments. I want to be able to instance an oscillator and have any number of, well, in my case it was a filter. I wanted to instance a low pass filter and have it be any order. So I wanted to be able to dial in however much I want to spin, right? And I don't want to have 50 precompiled header files just in a unique pointer array or something like that. It's just just more elegant to have it a constructor argument. So wouldn't it be great if GPT would just convert my Faust in C++? The macro argument would become a constructor parameter, and I would be there. And it can kind of do this. But 3.5 really could not do it, but I did use it. It was still helpful, and the reason was it was able to just translate from Faust function notation into C++ function notation, and I just had to make it real. And it was very straightforward, and got it done pretty fast. So this is the Faust low pass, which David showed you actually. You saw the low pass, and there's its order parameter. That's a compile time constant that's used in recursive pattern matching. And so I wanted to basically have that be a constructor parameter. So could I rewrite it in C++ using ChatGPT? And it worked out very well. And while I was at it, I said, make all the comments, put them all into Doxygen format. And that way I'll have a C++ class with a nice set of doxygen comments, and I can get a document page like the juice distribution does, and start doing that. And this is just a little motivation as to why I needed that. The juice oversampling function, it's in juice colon DSP colon oversampling. That thing is really nice. It's an elliptic function low pass filter for anti-aliasing protection. I think it's 11th order, if you count 2 poles per null here and get one pole here. And so, or these are counting the zeros, and there's the same number of zeros as poles. And so this is your elliptic low pass, and this is exactly half the sampling rate, and you can't really move that around. And so it's the sharpest transition from passband to stop band that you can get for a given order. And if this is 20 kilohertz, that's great. But if you're working at low sampling rates where this is a highly audible frequency, then you really hear the nature of this cutoff frequency. And if you don't like that, then you might want to go with a Butterworth. And that was the situation I was in, where down here I've got just like an amp cabinet, like a Marshall 212. I actually have an internet page on that. So this is the frequency response of a Marshall 412, and this is 4 kilohertz, I think. Or right here is 5 kilohertz. So you can see that above 4 kilohertz it just starts plummeting, and you just don't need. You don't need all the way out to 20 kilohertz. You can start rolling off much sooner, and you can do it with a much more gentle roll off. And so this is the Faust Butterworth order 5. And the reason you can reduce the order is because you've got so much distance to get down. And you don't have to get down by half the sampling rate. You have to get down by the image of your positive frequency. So let's say your cabinet goes out to here, then you need to be down by that distance below the sampling rate. In other words, a low pass spectrum, ends sooner, and it also starts up again later. So this is this is basic sampling rate conversion stuff. So you have all this room here in which to roll off gently, and that sounds better, and that's something I might be able to demonstrate. I'm not sure. So this is my development environment for strings and such. And so let's see if I can, looks like my screen size has changed. So up there is an impulse FFT, and wow, I can't even reach, I have to, I don't know why it does that. It resizes everything such that you can't reach anything that you need to move the window. That seems like a bug. Okay, now I can reach stuff. All right, so, but now I have to dial up the impulse test. So as a guitar player, I'm obsessed with sustain. So I have infinite sustain. Okay, maybe that's an organ now, you have to, but you can have as much sustain as you want, all right? So this is now exciting the string with an impulse. And so you should be able to see, you can hear it and see it. Let me turn that up a bit. I want to play the difference between elliptic and Butterworth. So that's a straight impulse, okay? And you see its spectrum popping up there. So I'm going to go to the strings menu, and I'm going to, here it is, an octave shaved off using that elliptic function low pass filter you saw. So you can see there's a missing top octave there. So I'll bring it down another octave. And let's bring it down. So now we're down converting by a whole factor of 8. So now you really hear that corner, right? That's the sound of an elliptic corner, 11th order, I believe. And now I'm going to switch it from elliptic to Butterworth. Quite different, right?
Yeah.
So that's butter. Here's elliptic. And to really accentuate it, let's go one more octave, and the graphics falls apart for some reason. You hear that ringy, even though it's not corner resonance, it's so sharp that it sounds like corner resonance, at least in my ears. So I always go for Butterworth whenever I can, if I've got the room and the spectrum. Use the minimum order, smoothest possible transitions in any kind of spectral shaping. That's just a general rule of thumb. Okay, and so that's what I needed it for, and ChatGPT did it, and it was, it was sort of speaking in tongues when it did it. It was funny because it would copy the Faust code dutifully, and it was good. There's a lot of C-looking Faust, right? And all that was fine. But then when it had to return like a biquad section or something like that, it would just return a Faust expression. And so I had to go in there and make that a biquad class. And so then I tried to use the GPT-4 to do it. And first I thought, well, let's just try to do it at the Faust level. Let's see if I can get rid of the pattern matching and just have it calculate the poles, in real time and do everything. And so here's how I described it. Said, in the Faust language, we can design an nth order Butterworth low pass using this, where the FC is a cutoff frequency in hertz. However, n must be known in compile time. Write a replacement for low pass that allows n to be any positive integer at runtime. And so here's its definition. It's in terms of select 2, and I don't know where it thinks how far 2 is going to go there. And as an example, it does it for 10. And so for each branch of the selection, it has a filter with a particular order. So this is kind of getting toward, my array of unique pointers solution, where you basically have a low pass. But what are these square brackets? How is it going to store this block diagram in this filter array in the Faust language? And select 2, here's your Boolean control, and this is false, and this is true. And what's this? And where's I? Where's I going from 0 to 9? So it's pretty far out to lunch in this particular example. It's and the next thing I said to it is that, well, yeah, all these low pass filters are going to be running full tilt all the time, right? So if I've got 50 low pass filters, I'm going to have 50 actual block diagrams from order 1 to 50 running at all times, and I'm going to switch. And its first response was, "You're right." I just enjoyed its sort of affirmation. You're right, Victor. And we just had it on from there, and we had an interesting discussion. And it ultimately said it just can't be done. GPT-4. I don't know why it thinks it knows that, but it just started planting its feet and saying no. And I finally got a new chat. But the final design was from 3.5, and it's fine. It looks a lot like the original Faust. So if you look at the original Faust, you'll see this is almost identical to it. And the only thing I had to add is a biquad class, because what it was trying to do was just return an expression. You don't do that in Faust, but it just would say, just as a give up shot, it would say return TF2S to recurse. But it was very easy to edit into a working final thing, and that's what I'm actually using. That's what you heard. You heard that code. Now, just to kind of round out the discussion of translation by ChatGPT, it worked out much more smoothly to translate a lot of my MATLAB into Python. I had this huge mountain of MATLAB that I'd like to have in Python. That it does really well. I'm just translating it as I need it. I can also go from MATLAB to C++. And I can take any comments in any random program and get them in Doxygen format. I'm getting good luck with unit tests, and if it's general purpose C++, it tends to be really right. And if it's signal processing, I usually need to spend a lot of time debugging it. It doesn't know signal processing very well. So even 3.5 saved time. I would say a lot of time. And GPT-4 has a much better understanding of the Faust language, but it's a very primitive, low-level, tutorial-level understanding. And it doesn't use the nicer parts of the language. But even when it's completely wrong, it has good ideas and usable outputs. And you really want to test it. So Faust is not as well known as, say, C++, and writing it manually is still the gold standard. But these language models are coming, in a year, who knows, right? Or as Aurelia said, in 90 minutes, who knows? At ADCX, he was giving a talk, sharing his experiences with GPT as well, and including a Faust example. So my meta zoomed out summary is that our current embodiment of real-time musical instruments using Faust is an iPad iOS device using touchscreen multi-touch and real-time physical models for getting the expressive musical instruments, and we miss touch, 3D touch. The iPhone 10X XS Max, that's my phone that I will not even loan out because it's got force touch and it's discontinued on the phone. But for iPad, there are things you can do. Romain Michon has the nuance system that puts 4 FSRs under the iPad, and that's enough for me. I really can get by with just one touch. I don't need all of my fingers to be, independently. I don't need polyphonic aftertouch. I just need channel pressure, as they say in the MIDI world. And I've also got some piezoelectric, FSR fingertips, but you have to wear a little processor on your wrist, so you can bring force back. But it's a pain. It'd be so much better if it was built in. And so the thing that's really great is to get a force-sensitive large touchscreen with high resolution and a very fast interface to an embedded processor that doesn't have to be bare metal. A Raspberry Pi, Elk Audio kind of thing would be great. So that's just where we are right now. And Faust remains the shortest known path to high performance C++ for audio synthesis and effects. And you probably want to do it by hand. And Juice is the best known framework for making audio plugins. If you want to make a plugin, get it out to the world on all the devices, and Juice will make your life a lot easier to do that. And then a shout out to Daniel Walsh for Plugin Doing Magic, which I still use. I'm really happy with. A lot of us use it, and so that's what's happening now. And I have some time for questions if anybody has any, and I have more demos I can play if you don't.